In this lesson, we'll continue our discussion of big idea number 1 and 2. How are organic compounds classified, and how does their structure determine their properties? Today, we will discuss aldehydes, ketones, and carboxylic acids. Both aldehydes and ketones are hydrocarbons with carbonyl functional groups, or C double-bonded O's. Aldehydes have the carbonyl on the end carbon. It's sometimes known as a formal group in other texts, and have the general formula RCHO. Ketones have the carbonyl attached inside the chain and have the general formula RCOR'. Now, I'm not sure why they didn't classify them as primary aldehydes and secondary aldehydes, because that would have worked too. Naming aldehydes and ketones. You follow your hydrocarbon rules and you use the suffix al, Al, for aldehydes and -one for ketones. The C double-bonded O groups take numbering priority over any other alkyl groups, but not double or triple bonds. For ketones, you have to add a position number for the carbonyl group in front of the suffix. You don't for aldehydes because it will usually be on carbon number 1. If there's more than one carbonyl group on your molecule, use a molecular prefix to indicate how many. And rule number 5, drop the E at the end of the parent name if the suffix begins with a vowel. Here are some examples. Looking at molecule A, my longest chain is the 4 carbons going horizontally across the page. That gives me the root bute, because they are all single bonded, ane. To indicate that I have a C double bonded O, I number the main chain so that that group gets the lowest possible number. Because the double bonded O is in the middle of the chain, this is a ketone. I would add a position number and use the suffix -one. Now, because my suffix begins with a vowel, I have to remove the E on the butane. My final name is butan-2-one. For molecule B, my main chain is 3 carbons. That gives me the root prop. Because they are single bonded, I would use ane as my suffix. I have a double bonded O at the end of the chain. This means that I have an aldehyde, and I need to use the suffix Al. I don't need a position number here, because aldehydes are always at the end carbon. So I would drop the E and add Al as my suffix. My final name is propan-al. Pause the video here and name molecule C, D, and E. For molecule C, the main chain is 5, giving me the root pent. Because they are all single bonded, I would use the suffix ane. I now need to describe the carbonyl and the methyl group attached to my main chain. The carbonyl gets the lowest number, so I would start my numbering on the right side of my parent chain. Because I have my carbonyl on carbon number 2, this is in the ketone family. I would add a position number and use the suffix -one. And because my suffix begins with a vowel, I have to remove the E on the pentane. The methyl group gets described in the prefix. The final name for molecule C is 3-methylpentan-2-one. Molecule D. The main chain is 5 carbons, giving me the root pent. They are all single bonded, so I use the suffix -ane. I have 3 carbonyl groups that are not at the ends of the chain, so this molecule belongs to the ketone family. I would number my main chain so that the carbonyl groups get the lowest possible number. In this case, it doesn't matter whether I start left or right. I would add position numbers, and because I have 3 carbonyls, I would use the suffix trione. Because my suffix starts with a consonant, I leave the E at the end of the pentane. The final name for molecule D is pentane 2,3,4-trione. The longest consecutive chain in molecule E is 6 carbons long, and I have to include this double bond. That gives me the root name hex, and because there is a double bond there, I need an -ene. But I also need a position number. My double bond is between carbon 3 and 4, whether I start numbering on the left or the right. Now I need to describe the 2 carbonyl groups at either end of the chain. Because they're at the ends, this is an aldehyde. You could put position numbers, but they are not necessary, because aldehydes always have to be at the end of the chain, and because carbons can't have 5 bonds, you can only have 1 carbonyl at the end of a chain. The final name for molecule E is hex 3-ene-1,6-dial, or hex 3-ene-dial. Properties of aldehydes and ketones. Because they have the same functional group, they roughly have the same melting point and solubility in water. Carbonyl functional groups are polar, which means that aldehydes and ketones can dipole-dipole with each other. This increases the melting point of an aldehyde or a ketone compared to an alkane. For solubility in water, there is no H directly attached to the O for the carbonyl group, but there is an O there. So the carbonyl can actually accept hydrogen bonds. This makes aldehydes and ketones have higher solubilities than alkanes do. Other interesting things about aldehydes and ketones. Just like amines, you can identify them by their smell. Aldehydes have a pungent smell, kind of earthy, while ketones have a sickly sweet smell, like you've had too many fuzzy peaches. They are both used to make perfumes. The main components of male colognes are aldehydes, whereas the main components of female perfumes are ketones. Both aldehydes and ketones are heavily used as solvents because they can dissolve both polar and nonpolar solutes. They have a nonpolar hydrocarbon end and a polar functional group that is not too polar that it would repel anything that is nonpolar.